Hello, welcome back to Z Lessons, where we continue to uncover these interesting circle theorems. In the previous video, we looked at this theorem, which was Theorem 6. You can check out the previous video and you'll be able to learn so much from there. We covered very important stuff. For today's video, we are going to look at Theorem 7, which talks about the cyclic quadrilateral. Okay, cyclic means that we are dealing with a second also. So we have different quadrilaterals. Let me go to our beloved app called GeoGebra. Before we deal with circles, let's just talk about quadrilaterals in general. A quadrilateral is just a polygon. Okay, polygon. By polygon we mean that it's formed by straight lines. So a quadrilateral is just a polygon with 4 angles. As you can see, this is a quadrilateral because it has what? 4 angles. Now I want you to see something right here. Let us measure the angles. Let us first measure angle D. Then let us measure angle A there. Then let us measure angle B. And lastly, let us measure angle what? Angle C. So if we move them, as you can see, these are separate angles like so. So now what I want to prove is that these angles, the facing angles, as we can see, we have what we call facing angles. You can see that this angle B is facing D and this angle A is facing C. So let me just add colors so that you can see them properly as they face each other. As you can see, C is facing A and D is facing B. So now I want us to look at this theorem very closely. It says that opposite angles in a cyclic quadrilateral sum to 180. So when we add the opposite angles, as you can see, A is opposite to C and D is opposite to B. As you can see, that's what they mean when they say opposite angles. So when you add angle A and C in a cyclic quadrilateral, meaning that it's in a circle, it should give you what? 180. So when you add opposite angles, they should give you 180. But now for us here, this is not in a what? In a circle. So I want us to add these angles here and see what will happen. Let me just do some computation here and I'll get back to you real quick. Okay, so this is what I've managed to come up with. In the theorem, it stated that the opposite angles in a cyclic quadrilateral sum to 180. Now, as you can see, if we add this angle, which I've represented by A, and this angle C, represented by C, if I add these two angles, look at what it's giving me, 168.7. And if I add this angle B and angle D, as you can see here, it's giving me 191.3. But why is this happening? The reason for that is that because these angles should be formed inside the circle. So the 4 vertices where the lines meet, okay, must touch a circle and they should be inside. Okay, so as you can see, it's saying that a cyclic quadrilateral is any quadrilateral which can be drawn with all 4 vertices touching a circle. So as you can see, this point here, this point, and that point should catch a circle. So let us add our circle right here. Okay, now that we have added our circle, let me just get rid of this real quick. Let us make our vertices touch the circle like so, and you see the magic begin to unfold here. Just watch and see what will happen. just like magic. This is magic. As you can see, in Africa, you can say that this is witchcraft. This is pure witchcraft. As you can see, we have a cyclic quadrilateral. And as you can see, this angle is opposite to C, and therefore it has given me 180. This angle has also given me 180. And as you can see, even if I move it and it looks very like crazy bad, you will see that it still holds true. This is just because that I'm using a mouse and the mouse is not stable, but as you can see, yeah, see, it's given me 180 as well. So this opposite angle, which is A, is opposite to C. When I add the two angles, it's given me 180, and so on and so forth. So this is what is going on. So this is just magnificent. This is wonderful. As you can see, this theorem holds true. So let me give you an instance of how a question can come in the exam, and we can call it a what? We can call it a day. So let me just get rid of all these angles like so. Let me just clear out. So in the exam, it might come that this is a cyclic quadrilateral. CDBE is a cyclic quadrilateral. Then we are told that find the angle B. So how do you do that? All you have to remember is that in a cyclic quadrilateral, opposite angles sum to 180. So now, since we already know that C is opposite to B, we know that this C plus this angle B, when we add them, should give you 180. So therefore, that means that we already have an angle here. All you have to do is subtract 96 from 180. So 180 minus 96, that gives us 84. So this means that 84 here is our angle. So let us prove that. Let us see if 84 is the angle. Let us measure this angle right here. And as you can see, just like that, we have solved another exam question. So therefore, that's how questions come in the exam, my friends. And as you can see, this is wonderful. This is wonderful stuff. I want to do something very nice and very complex here. So just give me a moment. Okay, as you can see, I have recreated this to show you what is happening. So as you can see from here, this is CB. This means that when we add angle C and angle B, as you can see, it's giving us 180. Also, when we add angle D and angle E, which are opposite, it gives us also 180. So as you can see, no matter how many times I drag it, even though the angles seem to be changing, as you can see, it maintains. As you can see, it's always, it's not going to change. So this is the rule happening right here. As you can see, if I want, I can make it let me just put it here so that you can see it properly. So as you can see, when I add angle C and angle B, the opposites, they always give me 180, because that's the rule. So if you add this and that, it's always going to be 180. Thank you so much. If you enjoyed this video, hopefully I wasn't rushing. If you're new to this channel, make sure you like and subscribe. Share this to your friends, your family, if you're a parent, to your children, okay? And see you in the next video where we're going to look at another interesting and useful theorem. So thank you so much and have a nice day.